The first shapes you're going to see are circles. The second shapes you're going to see are mixed up polygons. So you got to know the difference of what's what, okay? So in a circle, they're going to have two different types of circles, and I'm not going to do the ones on your sheet. You're going to do them. So they're going to have one that has a radius and one that has a diameter. And that's, you know, where people make mistakes is that they don't pay attention to what is being given. So let's say I have a radius of 20, and here we have a diameter of 15. Let's do 14. Let's do 14.
Not 15, please.
Let's do 14. Well, your calculator does a lot of the work. It's not a big deal.
Please no 15.
So here you go to your area formula sheet, and area of a circle is pi r squared, which I think is annoying. It should be r squared pi. If I rewrote textbooks, I would do it that way because it makes more sense. And all right, so the reason it makes sense to me is that on these equations, you can write the total number. You can put it all in your calculator and do it, but I like to gunk a pi. That means that I find radius squared and I put a pi behind it. Does everybody understand that?
No.
Because that's how you're going to see it on standardized tests, in pre-cal. The symbol pi goes on forever. It never ends. They haven't found the end to it yet. It might end, but they haven't found the end to it yet. So it's an irrational number, and you get a more accurate picture if you use the symbol pi than if you put 3.14 or you stick it in your calculator, okay? So as you guys, those of you who are going into science or things that are precise, like engineering or anything like that, you typically wouldn't put the pi in the calculator until the very end because it'll keep rounding and watering down your answer. And if you have to have a precision within, you know, a very small window, you're not going to make it. So that's when I tease about you guys sending food to the International Space Station and they open the dock door and there it goes because it missed it by that much. You know what I'm saying? So precision to me is important to teach because as you, depending what you go into, you might have to use it. So on the first one, the radius, let's call this number 1 and number 2. The radius is 20, so it's 20 squared times pi, which is 400 pi. For the second one, if the diameter is 14, the radius is half that much. So number 2 would be 49 pi. Easy peasy. So if the radius is 4, you would do 4 squared times pi, which is 16 pi. Done. When they give you the circumference, let's say they tell you the circumference is 10. Here you're going to have to use the pi button, and I'll explain why pretty easily, I think. The formula for circumference is diameter times pi. All right? Or 2 times the radius times the pi. Both of those are formulas for the circumference. This one has the circumference. Let's make it at 10.78. I don't care what the number is. You got a calculator, okay? So 10.78 is the circumference, and we need to find the radius in order to find the area of that circle, right? So I say 2 times the radius times pi equals 10.78. Now I can divide that by 2 pi. Doesn't it leave the radius alone? So here you will have to use your pi button. And tell me what the radius is. It's going to be an ugly decimal. It's okay. So we know the radius is 1.72, and it's real important to keep your work organized. Those of you who are organized will not make silly mistakes. And now we have to do radius squared times pi. So you just square that number before you round it. You just square it. And it's 2.94. Pi.
Is that how we get the circumference?
No. So this is a parallelogram. The dotted lines are showing you the height. The height of a figure is if you climb up on top and you jump down. If you jumped off that parallelogram, you wouldn't be going this way, like on this side. You would be going straight down to the ground, right? The height of that parallelogram is not the length of the side, it's the length of the distance that goes all the way down. Everybody get that?
Yep.
So in this case, 9.6 is the height. So I'm going to go to my formula sheet and find the area of a parallelogram. A equals base times height. So area, I like to do this. And I know that we don't have the area, but we have the base, which is 12. It's where it's sitting on the ground, times the height, times 9.6. And the area is whatever that is. Number 11 is a trapezoid. And here they give us the height, like if you jumped off the roof, is 4. And the base is 10. And this is 4.2. Everybody get that? So the formula for a trapezoid, and I like doing this, area of a trapezoid, area of a parallelogram, is 1/2 base 1 plus base 2 times the height. And the height could be in the front or the back, it doesn't matter. So base 1 plus base 2 is 1/2. This is base 1 and this is base 2 or vice versa. So it's 1/2, 14.2 times the height of that guy if you jump off the roof.
14.2.
So the area of a triangle is 1/2 base times height. Don't forget the 1/2 on a triangle.
I just did divide by 2 instead of.
Yeah.
It's the same
Half
thing.
and half.
It's the same thing. Is 2.8 times 1. So that is 1.4.